Hello, and welcome to the next session on linear equations. We're going to be covering some slope, um, how to write equations of a line using points and slope and y-intercept, etc. So we'll start on that today. We left off learning how to find the x and y-intercept and using that to graph an equation, as well as just graphing an equation with a table of values that you can select at random, or using that generic table of values, -2, -1, 0, 1, 2. So we're just going to kind of continue on from there. Okay, so this is the slide we left off on. So we're going to get started now today on slope. Slope of a line is a rate of change. So we talk about rise over run, typically, sometimes say grade or pitch, but usually we talk about rise over run. And if you think of rise and you think of, oh, my pen tool, where are you? If you think of a simple graph, right? This is a very bad drawing, but you have your x and your y axis. So my rise is how high up or down I go, so how much I rise, which would be my y axis, right? So it's the change in my y axis. So that's why rise y2 minus y1. So when we talk, we mean we have 2 points. So we have, we have x1, y1. Just going to rewrite that. So we have x1, y1, and then we have x2, y2. So we have 2 values that we're talking about. So we have a point, so 2 points on a line. So let's say the line looks like this. So we're taking a point here and maybe a point here. This is just a generic example. And we take our y value of the second point minus our y value of the first point, and then our x of the second point and our x of the first point. So it's y2 minus y1 over x2 minus x1. So we'll definitely look at more examples of this, but slope is rise over run, our rise being our y-axis and our run being our x-axis, so the change from here to here, so that horizontal change. So if an equation is linear, which is what we've only been looking at so far, a constant change in the x value corresponds to the constant change in the y value. So this means, for example, in this example, each time the x value increases by 3, so my x value goes 1, 2, 3, the y value increases by 2, so 1, 2. So specifically, if we looked at these 2 points, this point has an x value of 3 and a y value of 2, right? So this is your x1, y1. And then for this one, you have an x value of 0 and a y value of 1, 2, 3, 4. So this should have been a -4. I'm sorry. That makes sense because it should be a positive slope, yes, because it's increasing. Sorry to backtrack. It's just, it would have bothered me. And if it doesn't make sense to you, then this is why. So my x is 0, but my y2 is -4. So we have -1, -2, -3, -4. So we get -4, this isn't right, -4 minus y1 is -2. So I apologize for having totally messed this up. So my y1's -2 and my y2 is -4. So I have -4 minus -2 over 0, which was correct, minus my x value, which is 3. So I get -4 plus 2. So I get a -2 over -3 gives me a slope of +2 over 3, which makes sense, right? From those pictures we just looked at, this should be a positive slope. So I forgot my negative signs of my y value. So if you've done that, just know that you're not the only one. So let's move on to the next one. So sometimes we have slopes that have, so lines that have no slope, like this first picture here. So that has no slope. Or we say a slope of 0. In this one, it doesn't have no slope. We say that the slope is undefined. Oops. It's because of this thing. Sorry, I'm just going to move this out of the way. Oops, write it down here. Undefined. And the reason that this slope is 0 and this one's undefined is that my slope is my change in y, or my rise over my run, right? So here I have a rise or a change in slope of 0, but I have a run of infinity, right? Like it's a bunch of different numbers. So I know that I have my 0 on top. So this is going to give me a 0 no matter what I do. In this situation, it's the opposite. My rise is infinite. It's a bunch of different numbers. It's whatever number I pick. And my run is 0. And anything divided by 0, it does not exist, or we say DNE, or undefined. And if you were to punch this into your calculator would give you an error. So if you have a vertical line, so straight vertical, its slope is undefined. If you have a horizontal line, it has 0 slope, a slope of 0. This skier, and the reason they sort of describe it, I think, here is that this person is not going anywhere. Like it's going on this horizontal line pretty slow. This one is falling straight down, and it's like, eek, it's undefined. So they say that there's no slope. You're just falling forever straight down. Here we have the skier going up a slope. So it's actually going up, which is a positive slope. So this slope is positive. And this slope we say is negative because the skier is going down the hill, so it's getting more negative. So 0 slope, undefined slope, positive slope, negative slope. So we want to find the slope of a line that passes through each pair of points. So we have this formula y2 minus y1 over x2 minus x1. So we're going to say x1, y1, x2, y2. So let's do the first one first. So I have m, or slope, is equal to y2 minus y1 over x2 minus x1. So I gave my y2 to be 4, my y1 is 3, my x2 is 2, and my x1 is 1. Sorry, as I'm doing this. Okay, so we have our y2 of 4, our y1 of 3. So we have 4 take away 3, and then we have 2 take away 1. So 4 take away 3 is just 1, 2 take away 1 is 1. So I have a slope of 1. So we say m is equal to 1, or you can just use the word slope is equal to 1. That's fine too. For the second one, if you want to label your points like this, it's totally fine. I find it helps lots of students, even myself, when I go to label it so that I know which ones I'm putting where. So my y2 is negative 3, take away 0, because y1 is 0, over x2, which is 6, take away x1, which is 0. So I get negative 3 over 6, which is going to be negative 3 divided by 6, so negative 1 half, because 3 can go into itself once and into 6 twice. Or you could use your fraction button. So my slope, my rise is for every negative, so I go, my rise is negative 1 over 2. So I have a slope of negative 1 over 2. For question 3, my y2, so this looks similar to the one that we just kind of looked at. So you have those double negative values there. So we have a y2 of negative 2, take away a negative 5. So notice how this subtraction sign still stays there because the formula has it, but I also have a negative value. So I have subtract a negative. And then I have, I don't know why I'm writing on such an angle today. Then I have 1, take away 2. So negative 2 take away 5 is the same as negative 2 plus 5, right? Or you could just type that into your calculator all at once and it'll do it for you. But negative 2 plus 5 gives me a 3, positive, over negative 1. So the slope is a negative 3, because 3 divided by negative 1 is just negative 3. And we'll do number 4 over here. So I have take away my y1, which is 1, over my x2, which is 0, take away my x1, which is 3. 3 take away 1 is 2 over negative 3. So I have a slope of negative 2 over 3. So be really careful not to forget this negative value on the bottom. You can keep it on the bottom. There's nothing wrong with that. But in math, we like to bring that negative sign up to the top of the fraction. It's just like more proper, sort of like how, English has proper grammar. It's that sort of idea. So let's do the last one. Y2 is 4, take away a negative 8 over x1, which is 1, take away a negative 2. So this becomes a positive and this becomes a positive. So I get 8 plus 4 is 12 over 1 plus 2 is 3. So I get a 4. So my slope is a positive 4. So we were just asked to find the slope of the line that passes through the pair point. So that's how we calculate slope. if we're trying to find slope from a graph, like I did in that first example that I ended up doing improperly, we can use the graph of the line, and we're going to pick 2 points on the line. We typically try to pick a point that's on like the whole number, so 8 and -2, and then here we have one at 4 and or -4 and 4 rather. So we try to pick one that's not like a decimal or a fraction, preferably, because it's just much easier to calculate with, and you have a less chance of sort of messing it up, so to speak. There's also programs like in Excel, for example, that they'll actually calculate the equation of the line for you. And this is something you would look at probably like in our next level of math, if that's something you were interested in, or I mean, you could also just probably look it up on your own if that's something you're interested in, but we're going to try to learn how to do these by hand. So first, just asked to calculate the slope. So it says choose 2 points in the line. So we did -4 and 4, 8 and -2. Count the rise over the run, or you can use the slope formula. I like to use the slope formula. This one uses the rise. So from here to here, if I'm looking at my graph, I'm going to see how many do I go down till I reach this point. So I go down 6 and I go over 12. You could also do it. So your rise would be -6 over your run, which would be 12. Now we can also do my y2 minus y1 over x2 minus x1. So let's let this be x1, y1. And the question I probably would have gotten by now if I had students in class is, well, can I label this one as x1, y1, and this? Yes, you can definitely switch them around as long as you're being consistent. So I can't label this x2 and y1. This means it's my second point I've taken. I could make this my first point, but then it has to be x1, y1. So you can't put like an x2 and a y1 or a y1 and an x2 together, if that makes sense. You can definitely flip these around. The math will work out either way. So here my y2 is -2 over my y1, which is a +4. Oops. Oh, I did a comma, sorry, -4. So we have -2 minus 4, and then x2 is 8. Take away x1, which is -4. So I have -6 over 8. A double negative here, or subtracting a negative is the same as adding. So we get -6 over 12, which is the same as what we got here, right? We got our rise of -6 and our run of 12 by just counting the, sort of boxes, I guess, and then counting how much the run was this way. So we got the same thing, which is -1/2, and this could be reduced to -1/2. If you leave it as -6 over 12, I'm not going to take away marks. We do try to have it in the most reduced form as possible when we do create the equation of a line, which we're going to get to in the next couple of slides here. So we do try to have it in lowest terms. And if you were to type that into your calculator's all automatically going to put it into lowest terms for you, so you don't have to think about that part if you're using your calculator. Okay, so using slopes and intercepts to calculate, so we're going to eventually use slopes and intercepts to calculate the equation of a line. So we're going to start with what is an x-intercept, and we did look at this the last class, and we talked about how our x and y-intercept can actually be used to graph that linear equation. It seems to often be the easiest way because we're able to sub in those zeros, which is really helpful when we have maybe bigger numbers. So the x-intercept is the coordinate on the point where the graph of a line crosses the x-axis. So if I have a line like this, for example, I'm going to take a different color. So my y-axis is here and my x-intercept's here. So my x-intercept is the point, is the x-coordinate on the point where the graph of a line crosses the x-axis. So this is my x-axis. So this point is going to be my x-intercept. And then alternatively, this point where we crossed the y-axis is my y-intercept. And we can, if we have an equation of a line, we can look at the equation and we can figure out where our y-intercept and our x-intercept is by looking at the graph. But sometimes we don't know it. So what we can do is I notice that where my line crosses my x-intercept, my y is 0, right? So my x is some sort of value. I don't know what it is. That's the whole point of me calculating it. X is something. It looks maybe like a -4 or something, but we don't know because I haven't drawn this properly. But my y is definitely 0. So in order to calculate it for my x-intercept, I let y equals 0 if I'm calculating. And for my y-intercept, I do the opposite. I let x equal 0 because alternatively, when I have this line, I notice that my y is some sort of value. It looks like a positive, maybe 5 or so, but it's a positive value. But my x is definitely 0. It's nowhere on that x-axis. So then we talk about slope-intercept form, and there's a different type of different types of equations or forms of linear equations and parabolas and so on. But we're going to really just try to focus on and study the slope-intercept form of an equation. So slope-intercept form looks exactly like this. So y equals mx plus b. You may have seen this before if you've taken graphing in other courses. But if not, this probably will become very familiar to you by the end of this, or hopefully it should. So y equals mx plus b. So I already talked about in the last slides that we often use m for slope. So in this equation, that's exactly what m is. M is the slope, and b is the y-intercept. So this is b is my y-intercept, and m is my slope. Slope. X and y, I don't want to confuse you right now, but this part of the equation we usually use a point to sub in to solve for a missing value, or once we have the equation of a line, I can sub in any x and to figure out where my y coordinate is, or to sub this into my table of values and so on. But this is my slope intercept form. This is one of the most common forms that we write a linear equation out. It's like the neatest way, I guess. So slope intercept form, we're going to start with that one first. So y equals mx plus b. So again, slope and my y-intercept. Notice how my x-intercept isn't in this equation at all. And it's true. B is my y-intercept and my slope is in here. And then y and x are just values that you can put in for any point on that line. So an equation whose graph is a straight line is a linear equation. So we talked about this. Any straight line that we call linear, right, equation. And we talked about this now the third time. Y equals mx plus b. We have m being the slope, b being the y-intercept. And if you know the slope and where the line crosses the y-axis, we can use this form. If we don't, we can rearrange the formula to figure out those things. And we'll look at some situations that we're going to see to calculate. So for example, if I have this equation, y equals 3x plus 6, 3x plus 6, my slope is 3 because I pulled it, it's the number right in front of the x, right? So we have mx plus b. So the number that's in front or beside the x rather is going to be my slope. And then the other number, as long as the y is first, y equals something x plus 6, or plus b, we can say that my y-intercept is 6. So I have a slope of 3 and a y-intercept of 6. So here's another example. We have, I'm going to write this out. So we have y equals 4 over 5x take away 7. So my slope comes right beside the x, so it's 4 over 5, and my y-intercept is negative 7. So when we have this equation, the y has to be all by itself on the left side of the equation, or on one side of the equation, and then the other numbers are over here. To make it linear, the x can't have any exponent on it. There can't be more than one x in the equation, right? Unless you're combining terms, I guess, but you're going to have y on one side, and then you have something with your x, or maybe a 1 with your x, or maybe you don't have an x and you just have, a straight like a horizontal or a vertical line depending, but y equals mx plus b requires that y to be by itself on one side of the equation. And this is really important for this form to work. Why? If the y is not all by itself, then we must first use the rules of algebra to isolate the term y. So for example, we have 2y equals 8x plus 10. So you'll notice that in order to get y all by itself, so we look back at algebra. So right now there's an 8x and a 10, and that's fine. But I have this 2 with the y. So we know, so let's move down here. So we have 2y equals 8x plus 10. So our rules of algebra tell us that if I want to get this y by itself, which is my goal, I have to get rid of this 2. And y is being multiplied by 2. So to get rid of it, I have to divide by 2, right? That's going to cancel. But whatever I do to one side, I have to do to the other. And I have to do it to every term. So this 8x has to be divided by 2, and this 10 also has to be divided by 2. So I'm left with 8 over 2 is 4x and 10 over 2 is 5. So I now have my form in y equals mx plus b form. And now I can say that my slope is 4. So my m is 4 and my b is 5. So this is equation that a question that you'd probably see on your assignment or your test is you're given an equation, rearrange it to solve and find your slope or your y-intercept. And that's how we do it. We just use our rules of algebra. If you need to review your algebra rules, that's totally fine. You can go back and look at those books or visit previous videos. But yeah, that's what we're doing. We're just applying those algebra rules that we learned earlier in this course. Okay, getting back to the lesson. Your job is to write the equation of a line after you are given slope and y-intercept. So not that your job, I think that's a weird way to put it, but the question is asking for you to write the equation of a line. So let's say you're given m, you're given a slope of 2, and you're given b, you're given a y-intercept of 9. I know that my m is 2 and my b is 9. So now I can just sub these values into my equation and find my linear equation. So y equals 2x, because my m is 2 now, and my b is 9. So y equals 2x plus 9. So the equation of the line is 2x plus 9. Very similar, probably question you'd get. So if you're just given the slope and the y-intercept outright, you can just sub it right into that equation. And there you go. You've got your equation of a line because you've been given those values. So let's make sure we're experts at this. Let's try a couple more. So we have m equals 2, 3, and b equals -2. So we always start by writing the equation of our line. So y equals mx plus b. My m is 2/3. And my b is -12. So I could put the plus and then the minus, but I know it's just going to become an overall negative. So I'm just going to put 12. So my equation of a line is y equals 2x minus 12. And I'm done. And then our last one here, we start the same thing, mx plus b. You don't have to write this step down, but it's because I'm teaching it. My m is -5, so I have -5x. My b is -1, so subtract 1. So if it was a positive, it would have been +1, but because it's a negative, that plus sign will flip to that negative sign. So my equation of a line is y equals -5x minus 1 up here. So it's just a simple subbing in and filling in those letters that are holding the space in the equation. Okay, so here's another example. We won't do all of these, but it's the same thing. So given the slope and y-intercept, write the equation of a line in slope-intercept form. That's y equals mx plus b form. So let's do 1. So 3x minus 14, mx plus b. Number 2, -1/2 x plus 4. And I'm done. And then let's skip all the way to, well, let's just do them all. 3. Y equals -3 x minus 7. Number 4, y equals 1/2 x plus 0. So you can just rewrite this as 1/2 x because plus 0 is just going to disappear, right? So y equals 1/2 x. And then number 5, y equals 2x plus 4. Okay. So we can use slope-intercept form to find the slopes and y-intercepts. So the graph on the right shows the equation of a line both in standard form and slope-intercept form. Standard form just means we have an ax plus bx equals something like that, but it basically just means it's not rearranged, it's not in slope-intercept form. So if it's given in this form, we have to rewrite it in y equals mx plus b. So I have 6x, take away 3y equals 12. So I want it to look like y equals mx plus b. So the first thing I'm going to do is get rid of this 6x. So I'm going to bring it over. So I have -3 equals negative. I'm putting the x first because we know it has to come. Like we know it's mx plus b. So this 6x is basically being added to this side, right? So to get rid of it or to bring it over to this side, I have to subtract. So I get -6x plus 12, or you could have started by saying 12 minus 6x. It's the same thing, but I just put the 6x first. So -6x plus 12. then I need to get rid of this -3. And in order to do that, I have to divide by -3, but I have to do it to every term, right? I can't just divide the -6 by 3 and not do the 12. We have to do both. So -6 divided by 3 is 2x, and +12 divided by -3 is subtract 4. So now we have it in y equals mx plus b form, and we're done. So now I can say that my slope is 2, and my y-intercept, or my b, is -4. So it requires algebra to rearrange to solve for m and y, and b rather, for if you don't have answers. So we'll do a couple more. Use the slope-intercept form to write the equations, solve for y to determine the slope and the y-intercept. So our goal is to have this form, just like the last question. So I'm going to leave my y here, and I'm going to bring this 3x over. So I'm going to do what I just did. So I have -3x because it was a positive on that side, plus 14. Now I can't have a negative y, so I'm going to divide every term by -1 to get rid of it, because it's like having a -1 there, right? It's assumed that there's a 1 here. Mathematicians are lazy. So then we get -3 divided by -1 is 3, just positive 3x. Positive 14 divided by -1 becomes -14. So this is my slope-intercept form. So that means my slope is 3, and my y-intercept is -14. So I had to rearrange to find that. You could also say just m is 14. Okay, same thing here. We're going to leave the 2y on the left side. We're going to bring that x over, so it'll become a -x plus 8. Divide by 2. Every term gets divided by 2. So we get y equals -x over 2, or you could say -1/2 x. That works too. And then 8 divided by 2 is 4, so plus 4. So there's a 1 here. Okay, so remember, mathematicians are lazy, we don't write it. So our slope isn't just 2, it's -1/2, because that 2 is in the bottom. And my y-intercept, or my b, is +4. So this whole thing is my slope. I have a slope of 1/2. So again, this is just your algebra, so if you need to review that, feel free. That's okay. Sometimes we forget how to do things when we don't use it. I'll do a couple more. So what y by itself, I'm going to bring this 4x over. This time, it's going to become a positive 4x because it was a negative first, right? So we have 4x plus 6, and I'm done because there's nothing else attached to the y. So then my slope is 4, and my y-intercept is 6. We'll go down to this one, bring that 4x over. So I am going to get a -4x because it becomes a negative, right? Plus 9. Divide this by 3, this by 3, and this by 3 to get the y by itself. So I get y equals -4/3 x. 9 divided by 3 is plus 3. So all I did was divide. So I get -4/3 x plus 3, because 9 divided by 3 is 3. So my slope then is -4/3, and my y-intercept is 3. Last one here. I don't have anything to bring over, but I do have to divide by 5 to get rid of it, right? So I get y equals 3x over 5. Now, my slope is the one attached to my x, so it's 3 over 5. My y-intercept, it's not nothing. Like it doesn't, sorry, it exists. It just happens to be 0, because if I had a plus 0 in here, I would simplify and just write it like 3x over 5, right? It's not a 1, it's a 0. So I have a y-intercept of 0. So it just means it's intercepting at 0. So that means like here, it's intersecting here, right at the axis there. It didn't really go through, but you know what I mean, like right through there it goes. Okay, so sometimes we're asked to find the equation of a line given a slope and a point. So that one we were asked to find the slope and the y-intercept from the equation of the line. Now we're going to do the opposite. Suppose you know that a line passes through the point 3, 4 with a slope of 2. So it doesn't really tell me what the question is, but it's asking me to find the equation of the line. So I wrote out the steps ahead of time here. So the first step is going to be to sub the slope into y equals x plus b. So whenever I have a point and a slope. These are my steps. So the first step is to sub my m in. So my slope is 2, so I get 2x plus b. Sub it into this, right? So my 2 gets subbed into this equation. So now I have y equals 2x plus b. The problem is, though, I don't know b, and in order for me to have my equation of a line, I have to have y equals mx plus my y-intercept. So then this brings us to our step 2, which is to sub the given point in to what we found. So in to step 1 equation, I should say, for x equation to solve for b. So we started with, from step 1, y equals 2x plus b. Now my points I was given is 3 and 4. So this is my x and y value. That was given in the equation, right? That was given up here. So I've labeled it so that I know where my values go. So I'm going to sub in. I'm just going to pick a different color here. I'm going to sub in for y and for x using those values. So my y is 4, my x is 3, and my b shouldn't have anything in for it. The whole point of this is to solve and figure out what my y-intercept is or what b is. So 2 times 3 gives me 6. Now I'm going to use my algebra. Lots of students here are going to accidentally divide by 6. We don't want to do that. The 6 is actually being added to the b. So we're going to subtract 6 from both sides, which will go away. 4 take away 6 is negative 2. So that means that my b is negative 2. So I had 2x plus b, right? But now I know 2x minus 2. So I've calculated the equation of the line. I started with putting my slope in first, then using that point I was given to calculate my y-intercept. So I subbed it back into my equation to solve for b. And then once I have b and I already had my slope, I can rewrite my equation of a line, and then this answers the question. So my equation of my line for the point that passes through 3 and 4 with a slope of 2 is y equals 2x minus 2. So these steps are always the same when I'm given a slope and a point, but sometimes we need to find the equation of a line if we're given 2 points. So we're not given the slope at all, we're just given 2 sets of points. And sorry, this keeps blocking my view. The system for this also is the same. So we have step 1. Unlike the last step, we were just able to sub the slope into our equation, but step 1 is going to require us to find the slope. So we know that to find our slope, it's y2 minus y1 over x2 minus x1. So my points that I was given are 3 and negative 4 and negative 1 and 4. I've already done the math down here, but I shouldn't have done that. I should have just left it blank, but let's look up here. So I have x1, x2, oh, sorry. Oh my goodness. x1, y1, x2, y2. So I'm going to go back down here. So I have y2 is 4, take away y1, which is negative 4, over x2, which is negative 1, minus x1, which is 3. So this is going to create that double sign there. So 4 take away a negative will become a positive, so that becomes a positive 8. Negative 1 take away 3 is negative 4. So 8 divided by negative 4 gives me negative 2. So I've just subbed those into my slope formula. That's why I taught you slope first, like how to calculate this before we got into this. So I've calculated my slope. Now the second step is the same as in the previous problem. So remember in this one, my first step was just sub the slope into that equation and then solve using a point. So we had to calculate our slope because it wasn't given, and that's okay. Now we're going to choose, important here, either point. The question I get is which point do I choose? Doesn't matter. Any one, so either of these points, so this point or this point will work. I've chosen 3 and negative 4. Okay. And we're going to solve for b, so it doesn't matter. We've picked this one. So this is my x and this is my y. If you used a different point, you get the same answer. So for y is negative 4, m is negative 2, right? Maybe I should start by writing that part out first, so as not to lose you. Okay. So we found our slope. So now instead of just mx plus b, we have negative 2x plus b because I found my slope. So now I'm going to sub in my y. So my y is negative 4, my x is 3. So I get negative 4 equals negative 6 plus b, add 6, sorry. So negative 4 plus 6 gives me 2 is equal to b. So now I have my b is 2 and my m is negative 2. So now I'm going to substitute it all back in, and that's my equation of a line. So negative 2x plus 2. That's my equation of a line. Oops, I didn't mean to do that. So to recap, if I'm given 2 points, so 2 sets of points, I have to calculate my slope first. Once I've calculated that, I can sub that into my y equals mx plus b equation, pick either of the points, doesn't matter which one, sub it in and solve for b. Once I've solved for b, then I have both things that I need to write my equation of a line. So now I can just write y equals mx plus b. So I have 2 examples here. I did pick these 2 instead of just doing the scenario where you have a slope and equation of a line. I did 2 points just because they do require some more steps. So we're gonna, what happened to my, oops, no. Ah, oh boy, what did I do? Okay, so I have -1, -6, 2, and 6. So let's call this x1, y1, x2, y2, because I know that my slope has to be calculated first using the formula. You can always have this formula just in front of you. You don't have to memorize it, though it's not a tough one too. So my y2 is 6, my y1 is -6 over x2, which is 2, take away x1, which is -1. So I have 6 take away -6 over 2 minus -1. So 6 take away -6 is going to be like adding, so I get 12. 2 take away -1 is going to be the same thing, so it'll be like adding, so I get 12 over 3, which gives me a slope of 4. So now I have, I have y equals 4x plus b. That's all I have. That's what this gave me. It gave me my slope. So now I'm going to write that slope in with my slope intercept form. So y equals mx plus b, right? So the slope goes in for m. Now I can pick either point. Pick either point. Doesn't matter which one. I'm going to pick 2 and 6 this time, just because I felt like it. And I'm going to let this be my x and this by y, of course, because x comes first, y comes second. So I'm going to sub it back into that equation. So my y is now 6. My x is 2. So remember, I'm just taking this equation and putting my values in to solve for b. 6 equals 8 plus b. Subtract 8 from both sides. 6 take away 8 is -2 is equal to b. So I have an equation of 4x minus 2. So that's my equation of a line. I calculated my slope to be 4 and my b to be -2. This is my format, so I can just plug those in, and that gives me the equation of a line in slope-intercept form. Do the next one. So I have x1, y1, x2, y2. So I have 1 take away 5 over 3 take away 0. -4 over 3, so -4/3. Not a fun, it's fractions, which freaks people up, but that's okay. So I have -4/3 x plus b. So now I'm going to pick any point. I'm going to pick 0 and 5, my x and my y. I'm going to sub that point in. So pick either point, sub it in. My y is 5. My x is 0, which makes this much easier, which is why I picked this one. This becomes a 0, right? So I get 5 is equal to b. And my equation is -4/3 x plus 5. And I'm done. I just used those values to calculate for b. So same steps in every single scenario that has 2, well, not scenario, but in the scenario that has 2 points or 2 sets of points given, you do these steps exactly each time. So that's definitely an equation or a question that's going to be on your assignment. And then the other style of question will be where you're given slope, like we are here, right? Oops, we were given slope and a point. So we didn't have to calculate slope using m equals y2 minus y1. We just subbed it right in. We skipped right to this step, then picked, well, we only have 1 point to choose from, so we just used that point and we calculated. So that's the only difference. So those, we're going to stop there today just because I do find this unit to be quite heavy. So we're going to stop there. That's going to probably cover, maybe half of your assignment. And then the next class, we're going to talk about graphing. Well, we're going to do translations, I think, and then parabolas. So we'll stop there today and we'll pick up from there the next time. And thank you so much for bearing with me and letting me make my mistakes. Mistakes are okay. I also like when I make mistakes because it teaches my students that everybody makes mistakes, even those of us who teach. It happens. So if you have any questions, as usual, shoot me an email or ask your teacher, and I'll see you next time.